All right. Thank you. Good morning, good afternoon, good evening, everybody. My name is Niraj Kumar, and I host Azure Talk on a weekly basis. And in past, we have conducted more than 26 sessions on different topics on Azure. And in continuation to our early, sessions, this time around we have chosen topic called Azure DevOps, and I'm joined by two of great minds, Ashish Raj, who is senior DevOps engineer with Cyber Group Incorporation. So he has agreed to volunteer and take these sessions. Today, I'm also joined by Deepak Singh Dhami, who is an MVP. Just to give you an idea, what is MVP? It's Microsoft Valuable Professional. So Microsoft chooses globally, they confer MVP awards to all those professionals who carried very deep knowledge in Microsoft technology, and plus, they always willing to share their knowledge with the greater audience and greater community. So Deepak is an MVP in PowerShell, so he has also taken out time to deliver this session. So Ashish and Deepak both will run sessions for DevOps. And in case if you have any questions, please do feel free to type those questions in chat. For housekeeping purposes, I have muted all the audience so that we maintain the quality of our session and we don't get disturbed. So I really apologize for that in advance. But if you have any questions, feel free to type in the chat. And if you really need to speak up, you can raise your hands, or you can type in the chat. We can unmute yourself and we can take those questions. With that, if you really want us to, if you want to follow us, we also have Azure Talk group and Azure DevOps group. So you can join those groups, and if you have any questions, you can post those questions there. We have more than 2,000, almost or close to 2,000 members in Azure Talk group, and we have around 400 members in Azure DevOps group. So please do feel free to join these two groups. And in case you want to connect with us, you can connect with on Twitter, LinkedIn, or all those details are on these slides, and you are more than welcome to connect with us. With that, I'll move on to the agenda. What are we going to cover today? So in terms of the the topics that we have decided that we are going to cover, and mind this is one of the sessions in a series of sessions for DevOps. And we'll have more sessions coming up. So this is the session where we'll talk about introduction, or we'll introduce you to what is DevOps, and in terms of what really constitutes DevOps and why we call it DevOps. So we'll cover those, and Ashish and Deepak both will go through the DevOps journey with you. Then we'll talk about DevOps practice. What really as a DevOps organization, what practices you should adopt and what practices you should discard, because it's not about only adopting new things. It's also about learning new things and unlearning the old way of habits. Then we'll get into habits. I really picked the word habits. So like in DevOps habits, what is the culture? You can also talk about DevOps habits or DevOps culture. How do we develop that, and what really constitute the DevOps culture? Finally, we will move into the sustainable DevOps. So once you have implemented DevOps, how do you maintain that continuum and maintain that same level of intensity to deliver the DevOps model within your organization? And at last, but not least, we will also cover the infrastructure as code and DevOps in Azure. How do we do that? And as I said, these are introductory sessions, so we may not go deeper, but we have more sessions lined up where we will cover each of the pillar in much deep, and we'll go deeper down into the technology. So this is what the agenda is. With that, I will hand over to Ashish and Deepak. So Ashish, you can unmute yourself.
Okay, thanks, Niraj. Okay, so hello everyone, and today, as Niraj has given the introduction about the session, what we are going to have and the agenda. So today's session is about more of the philosophy revolving around DevOps. I mean, what are the things you should have in your mind whenever you are, actually you want to embrace the culture of DevOps in your organization. So that's what today's session will be. And moving forward, we will be discussing tool sets and specific demos in coming sessions. So it is series of session we are going to conduct in future as well. So let's get started, and let's first understand what is DevOps. So if you are, if you have done any of the, if you have read anything about DevOps, then most of the time the definition, the common definition across industry of DevOps is DevOps is the union of people, process, and tools to enable continuous delivery of value to end users. Now, so what exactly does it mean, and why we always see this definition on every first page of DevOps discussion? So I mean, I have seen that from different people who want to include DevOps into their organization. They first talk about tools. So which is the first mistake of person who wants to include DevOps or want to get into the mindset of DevOps. So the first two things you should keep in mind, that people and process, and that only define the tools you are going to use. So that's how a DevOps journey starts, and that's why this definition is very important to understand before jumping into the discussion of DevOps. So what do we mean by people and process and tools? So the people is the organization which is already delivering software, and DevOps comes into the picture when actually you are not up to the speed of the delivery to the delivery of user values or the delivery values to the end user. So that's when you think of DevOps, and that's when you first have to understand what the people you have in your organization, as well as the users you are talking about, the whom you are going to service. And then the process. So process defines how those people act, right? I mean, the process will only, the process will be the enabler for the people. How should they act so that the software or the end product will be delivered to the end user. So those process, when you talk about DevOps, you have to think about the processes you are right now having, and then how you can improve them. And then when you have discussed these two things, or you have a brief idea of these two things in your organization, then you talk about tools, right? I mean, what are the tool sets available for implementing those processes which can help those people to come into the DevOps mindset? So that's how this definition definition is actually the whole I would say the whole concept of DevOps defined within this simple line. So that's how you should look into this, and that's how you will be able to relate your current position with the DevOps. I mean, you are going to how you are going to improve on it.
So Ashish,
And
while you talked about people, process, and tools, so you meant people. By people, you meant the team and how you structure your team, and by process, you meant how to take the code from development into production, and the tools, different tools like Visual Studio, VSTS, and Jenkins and Jira. These are the things that you referred when you meant people, process, and tools.
Exactly. So that's what I meant. So people, what people you are talking about? I mean, what exactly they do? I mean, is this a software development team? Is this an infrastructure people? So those people, and then you talk about processes. What process you are using, like Agile or Scrum or maybe ITIL? or maybe, I mean, what exactly CMM? So what exactly the standard process, which is, which is actually you are using for, to help people to deliver the software, and then the tools. So I mean, there are many tools, which will help you to implement DevOps, like, as you said, VSTS, and then VSTS is complete, having complete set of tools, like, they have CI pipeline and all those things. But then you have different tool sets from open source as well, like GitHub, and then, Octopus, and I mean, Chef, Puppet, all of it. So that's what we talk about tools, right? So as you said, this is what we mean. And now the next point is OODA. So what OODA is? OODA is a term given by one of the U.S. Army colonel, who actually coined this term as a military combat situation, to handle the military combat situation, how they can react to the the problems they face during the combat. So this particular thing helps us to implement DevOps in our organization as well. So what exactly that means? So as you see that there are 4 things, observe, orient, decide, and act. So the first pillar of that particular methodology is observe. So you observe the things what you have right now, using the monitoring data, using the processes you have, the process documents you have, having interview of people, in your current organization, or maybe the users' feedback. Observe is like, you are evaluating your current status, and depending upon observation, you orient. So what exactly means orient is, in this phase, you will try to find the problems, what are the problems you have in your current state. It might be your infrastructure team, it might be your development team, it might be your project management, it might be feedback system from the user, like, monitoring system, it might be testing, it can be anything. So depending upon the data you get from observe, the orient will be derived. So once you have the orientation, once you know what the problems are and that needs to be fixed to help you improve on the side of delivering the end result, you will decide. So once you have the options to what are the things you need to improve on during the orient phase, you will decide which one should have the highest priority, and what are the things you should be, what are the tool sets you might be using, what are the cultural changes you will be implementing into across the team, and what are the changes related to process you might be doing. So those things you will be deciding in the decide phase. And then the final step is act, where you will act decisively, that you will implement the tool set with a standard timeline, so that you can give a faster delivery, which is part of the next point. That's the whole idea of having DevOps in your organization. Whether you are an infrastructure team, whether you are a development team, whether you are a project management team, the whole everyone's objective is like delivering the values to the user as soon as possible. So that's how OODA will help you to achieve that. So that's what, once you have the OODA in your mind, you will be able to understand the DevOps definition, what we have discussed earlier, people, process, and tools, very effectively, how you are going to prioritize those things over there. And then we have why DevOps. So
so Ashish, if I may interrupt, so you said the concept starts with observe, so that means we'll have to look at our existing process, and we have to see where we are lacking, where there is a deficiency, and where we can really find out the problem. So that's the observation phase. Once you observe, then
observation is only getting the data, to evaluating what are the problems you have. That's the orient phase.
Okay, all right, good. So then deciding the problem, what kind of problem you have, that is where you do the orientation phase. So once you have found out what the problem is, you decide on what problems to fix. And you make those decisions, and then finally, once the decision is made, you start implementing the plan of action, and to remediate those problems.
Right. That's exactly excellent. I mean, this is what OODA is, and this is what in nutshell, this is what DevOps is as well. I mean, DevOps came into the picture. We will talk about it in the next slide. Why DevOps, how DevOps is, what is the DevOps life cycle, and how this thing helping you. So, okay, now why DevOps? This is the question that I mean, most of the people, we already know that DevOps is something all the organization wants to include into all of their organizations. But why they are organized? I mean, why they are very much why all the CIO or CTOs are excited about it? You should really read the one of the famous report by Puppet Labs. So Puppet is a tool for configuration management, and they also do a lot of research for DevOps. So you should definitely go for this report. You just Google it with this name, and you will get a PDF file from that website. And when you read it, you should be you will be able to see they actually give a evaluation of what are the benefits different organizations are having, and what are the common practices among DevOps, and what a normal engineer they actually conduct interviews across organizations, so engineer as well as CIO, as well as CTOs, as well as managers, project managers. So you will get a feel of it, why DevOps is getting so much popular, and how you are going to embrace it within your organization. And the end product of DevOps is definitely the faster delivery cycle. You will be able to deliver your product faster than your traditional methodology, whatever you are following right now. So definitely that's the end result. I mean, that's the end result everyone wants to have, and that's what DevOps will give you. And once we have once we have the understanding of what DevOps is all about and how you are going to use it in your organization, we are going to talk about change agent for DevOps. So change agent is like, how you can become change agent. And here, Deepak can help me, to give his perspective here.
Okay, as Ashish already has thrown light on the topic DevOps, I would like to just pitch in my side of it. So for me, DevOps is basically following a culture where you collaborate with everyone in your team, you communicate with them, and you continuously learn and improve. The definition is obviously the official definition, but the way you embrace it, the way you manifest it in yours, in your team or in your personal life would be obviously different from others. And basically change agent is someone who sort of brings that change into an organization. Like, you don't have to wait for your entire team to adopt DevOps. You could basically start with yourself. And why, the first thing is change is always people are a bit worried when there's a change. If you tell a person that who has been doing a process for 10 years that no, this is probably not the efficient way of doing things, there's supposed to be some sort of friction, right? So I'd like to share how I started on my journey of DevOps. I work as a PowerShell scripter in my team, and my day job includes writing code. Okay, and so what I could do is just go in there, just do my work and come out. I don't have to worry about anything, right? My job is safe. But that's not how DevOps works, right? Because it's sort of a mindset where you say, where you go and you look at other persons, how they are doing their stuff, talk with them, communicate with them, identify the pain points. Like when I went into the team, I identified that, okay, we were doing firmware cycles, like we were doing patch updates on the servers manually. So what I did, I just proposed the idea, hey, why don't we do it? Why don't we automate it? So the that's how you sort of work with the team, identify the pain points, and you don't have to like suddenly change the entire thing. You have to like start small. You don't have to focus on the big picture as soon as you jump into a team. And as you try to bring in more efficiency, like as you start automating small stuff, and your team would eventually be more embracing the culture of where they communicate with each other, help each other, collaborate with each other, and that's how eventually you would be practicing DevOps. So you don't have to wait for your manager to that you have to embrace DevOps. You could be the change agent within your organization, which drives this culture.
Yeah.
So DevOps is not a tool. It's sort of a mindset. It's sort of a culture. Many people say that they continuously like to learn, they like to evolve. So DevOps is basically that being applied now to everything, be it software development, be it infrastructure development, infrastructure testing. So it's basically sort of a mindset and culture.
Yeah. So
and
just
you can be the change agent.
yeah. Thank you, Deepak, for adding on. So just to, reiterate what Deepak said, it's a mindset. And it's a mindset, you need change agent. You need people who are early adopters, who is ready to get out of their comfort zone and, try to look at the existing process and say, hey, this we are not doing right, and this is how we should write. So object and propose. So you look at the existing process, you look at the existing, work that you're doing, and you say that, oh, maybe we may be doing it right, but we are not doing it efficiently. We're not doing it, correctly. So let's look at this, and then you propose a solution. Also, it's all about like looking at the existing problem and then proposing a new solution. So, and you are also, the change agents are the early adopters, the one who drives the change within organization. All right, thank you. So let's move on to the next slide.
Okay. Yeah, right. As Deepak said, and as Niraj also emphasized, that it's a culture, and definitely it's a culture. No matter how much definition, how many tools you are going to understand or learn, no matter how much definitions you will learn or remember, but it's all about the change agent, which will actually define the organization in maturity about DevOps. So change agent, wherever you are right now, whatever you are doing right now, whether you are an infrastructure engineer, infrastructure developer, or a tester, or a developer, a software developer, or maybe a project manager. All includes, as a change agent. You have to think about what you are doing right now, and from the perspective of OODA and the perspective of people, process, and tools, you will try to understand how you are going to improve it. And that's what DevOps is. It's not about fancy tool sets. It's about how you're going to change, how you're going to deliver faster than what you are doing right now. Now let's just go back to our DevOps life cycle. So this life cycle defines how actually it's a brief picture how people, process, and the pipeline works across DevOps. A DevOps organization. So the first thing which you can see here is development from the extreme left. That's the main thing which which actually forced organization to to include other organizations into DevOps. So what happened to development is development teams started adopting Agile. So Agile, as you might be aware, that it's all about faster delivery. Faster fail, faster delivery. That's what Agile is. Now, when software development team got started with Agile and they got the product delivered faster, Then the operations team, as you can see in the, in the after the collaboration, the production team, which is the operations team, they had the, the responsibility of delivering the end result of the software to the end user. So as you know that, only code is nothing. I mean, if your code is just residing over the code base on the repository and it's not getting delivered on the production as a live site, then it's nothing. I mean, it has no value. So the, the responsibility of production team also got, got more expectation from the agile that they have to, faster their release cycle as well, what you call, or deployment. So that's when the production think about the automated way of delivering product, and that you can see in the bottom side where there are multiple, server boxes and aligned with those, gearboxes, which defines that these things from development to the production should be automated using the CI pipeline, using the CD pipeline, release pipeline, what you call, and that's how the delivery of the, value to the users will be achieved, and that's what the organization goal is. Organization goal is not just updating the code. Organization goal is getting that code into the live site, into the production, and that's where DevOps culture or the mindset, as Deepak has explained, as Niraj has also emphasized, comes into the picture. So if you are sitting there in the infrastructure, you can relate DevOps as much as a developer can relate it with, because the both should have the same vision of delivering the product to the end user as soon as possible. Now, as you can see, there is a backlog on the on the top, which defines the ongoing improvement from the development side. But then how will this backlog, will be generated? So one way of generating backlog is from the business side. The business comes up with the new feature request, and then, your development team will start working on it depending upon their methodology, maybe Agile, maybe Scrum, or maybe Kanban. But the one way of getting information about backlog is the business. But then, as your site is already there must be observation. If you know the OODA loop, there is an observation phase on the first site. So you should observe your application in the running site as well, and you should get the application monitoring there, and then using that telemetry data, you should give the feedback to the backlog as well. Okay, so these are the things, in the live site are not working as expected, or might be throwing errors for some users, and that would be another backlog item apart from the business to the development team. So that's what the life cycle is, and that's how wherever you are, maybe infrastructure, maybe development, or maybe a business user, all are in the DevOps. All should be think about it. All should be think like that. So that's how. That's all DevOps life cycle is, as we explained.
All right. There is a question from Ruksar. He's saying, "Is DevOps culture build team as self-sufficient and independent, regardless of automation, testing, release, and CI/CD, or in regards to it?"
So yeah, that's our next topic, which is part of our DevOps habits. Not next, but next to next. But okay, I will explain here is, that in a DevOps culture, teams should be autonomous, as well as they should be aligned with the with the organization vision as well. So as you said, they are self-sufficient. Yes, they should be able to do their duty or do their job. But at the same time, when they are performing their duty, they should keep in mind the overall organization goal of delivering the end product to the users. So it's not like that DevOps do embrace that the team should be working closely. They should know each other. They should they should know each other's responsibility. At the same time, they should be collaborating to achieve the the organization alignment. We will talk about it in our DevOps habits. It's part of DevOps habits.
Sure. Let's move on to the next one.
Okay, so in DevOps practices, the first thing comes into the picture is configuration management. And as you can see in the DevOps Infinity picture in the right side, that the first part from the extreme right, it's configure. So configure is, something majorly the operations team responsible for it. That's why you see that ops, responsible for most of the configuration. It is not a shared responsibility with dev. And configuration includes infrastructure as code and configuration as code. Maybe Deepak can, give his perspective of configuration management.
Yep. So as Ashish mentioned that, okay, there has like the ops team was ideally the bottleneck. As soon as dev teams started practicing agile, they were like punching features more regularly, and the bottleneck was mostly the ops team, which were like procuring the hardware, provisioning stuff on it, manually installing stuff on it. So then at some point in time, because that's not feasible, right? You suppose the devs want to deploy 1,000 features and you are doing stuff manually, that's not feasible. So automation came into picture, and people sort of started thinking that automation is DevOps, but it is not. So ops team, what they started thinking of was like the earlier approach of automation was they would create this big image, the OS like OS VHD file, which will have everything on inside it, but things started happening wrong that way because the configuration would drift when the application code would be deployed. So the Puppet Labs, they published a report saying that if you start with the initial base image, then when the application gets deployed on top of it, it has already, most of the time, it gets drifted from it. So that's when the configuration management practice came into picture, where you would deploy the bare minimum system, the OS on it, and then you'd have something like a tool which will take your declarative syntax and then apply it on top of the OS, making sure that it's always in place. So suppose your app requires all the dependencies, the file system structure, the required registry punches, the configuration management software will take care of it.
So Deepak, while we are on here, so could you define what do we mean by configuration for the audience? Because a lot of audience here, they're not sure about what do you mean by configuration. So give just examples. Yeah. Okay.
Yeah. Sorry. So configuration could be anything which your application might require. Suppose your application requires a particular file to be present, right? Suppose you are running a web server. Mm-hmm. So you make sure that the index.html, which the developers developed, has to be checked out and placed into a particular folder. So that's one example of configuration. Another example could be you want a particular registry to be modified in order for the application to optimally work. So all those things where you sort of change the state of this system would be configurations. That's and good. If you do it manually, what will happen is the human errors will start creeping in. You don't want to do those things manually.
So basically the configuration is inside the application or inside the operating system. If I'm an infrastructure guy. So for me, if I talk about operating system, so let's say installing IIS on top of that is a one configuration change. Making a registry change in OS, that's another configuration change, right? Or making sure that my DC promo or Active Directory promotion has required log files and making sure those files are there. So that's another example of configuration from infrastructure perspective.
Yep, right? Exactly. Yeah, and configuration management would ideally fall inside infrastructure as code. Because what you're doing now is taking the best practices which developers used to use same set of tools, something like a version control, and have a sort of a declarative file. If you're using Windows, then you would be familiar with something called DSC. DSC is a document where you define you want this state of the system in this particular this particular state, and you do not worry about how that state is met. You just declare, and you don't do the normal way of defining things, like where you would go ahead and write the code. So what it does is basically makes your life easy. Like somebody already has written the code, shared with the community, you just go ahead and use it. And the other term which is being thrown around is configuration as code, which basically means that alongside your configuration documents, which live inside your repository, you'll also have something called the configuration files, or the environment metadata, which will be living side by side. So suppose you might be installing different packages on different environments, depending on if they are production or staging. So what you ideally want to do is you want to make your code independent of the environment data. So that will lead you to decoupling these two things and storing your configuration inside your version control in a separate way. So basically both of them are related. So if you are familiar with PowerShell scripting, think of it as, suppose you're executing a function, you don't want to hard code things inside your script, because these things you want your system to be flexible enough to like pick another parameters from another file or something like that.
So
Probably
basically,
environment details.
yeah, basically, if my code requires certain parameters, certain inputs, instead of hard coding that, we can put it in a declarative template, and from there we can call it those variables.
Yeah.
All right, good. So let's move on to the next one.
Okay, so yeah, continuous integration. So I mean, before coming to the continuous integration, because infrastructure as code is something I am, very much excited about. So I will take few, 1 or 2 minutes to discuss this one again. And as Niraj and Deepak has explained, it is all about committing your code, for infrastructure as well. So that's where I want all the infrastructure people to concentrate over here, that, you can, in DevOps, infrastructure plays equal role. I mean, equal role, that means you people, infrastructure people are going to use the same tool sets like coding, version control, or maybe the deployment, release cycle, or, declarative code, as Deepak has said that PowerShell DSC is one of them, Chef, Puppet, all of them are declarative, support declarative scripts. So those things will help you to create your infrastructure in terms of code, and that code will be helping you to avoid Snowflake servers. So Snowflake is something, as Deepak has said, that there will be a environment drift if you will do it manually. Suppose you have deployed a server using manual step, then there will be a patch coming into the server on which you do not have any control over. And then what will happen there, if you have a test environment and if you have a production environment, the test will have might be missing that particular patch, and production will have that patch, and that patch is very vulnerable, which can cause issues with your application. The application you are hosting. So test will not be able to detect that, and at the same time, the production will be impacted because testing has been done and you will deploy on production, and that's where you will find it. However, if you have coded it, the infrastructure has been coded, and the configuration management has been used to control the configuration of the servers across the environment, like test, quality, QA, or maybe production, then what will happen, that patch, as soon as it gets installed on the production, you have the control whether you want to install it or not, the first thing. The second thing is, maybe even if it gets installed, the DSC or any other device state tool, which might be Chef, Puppet, or Ansible, which makes sure that that particular configuration should be the same what expected from the code base. So that's, that is very important to have configuration management as a code, and the subcategories are infrastructure as code as well as configuration as code, and that's the primary role of operations. So
So So Ashish, just sorry to interrupt you. You talked about Snowflake servers. Could you explain a little bit what is Snowflake servers?
Okay, Snowflake term is used for a server like when there is a configuration drift across the server which is supposed to have a same configuration. Like suppose as I give an example of test, QA, and prod environment. So any ideal environment for an application will have these three environment like and these three should be same in terms of configuration. Now, what happens in traditional way of managing the servers that some of the servers will have some patches installed, some of the servers will not have some patches installed, and some of the servers might not be even updated for a very brief time. And what will happen that yeah.
So what I understood is this Snowflake is the term used to demonstrate or really point out the configuration drift between dev, UAT, prod, UAT, dev, and QA different environments.
Right. If there is a drift in your environment, then these servers we call, the term is Snowflake server, and you have to avoid it. You should be avoiding it. And infrastructure as code and configuration as code, it helps you to manage it very easily. Those who are coming from operations background, they are very much familiar with this situation where a particular patch got installed on one of the server and the application is failing over there, and they are just digging it out which particular patch is causing issue because the test environment is just working fine. And if they would have used infrastructure as code and configuration as code, then they would have the control to install the patches, and they would have known that this particular configuration change has been done on maybe test environment or maybe in the production environment, which might be causing, because this is the drift we have in the configuration management checked into the code, because code will give you the difference. Like in one of the server in the code you have written that okay, IS should be present, and one of the for test server in the configuration management, in the code you say that it should be absent. So you have a very clear picture of how the configuration is drifting, instead of going into the logs, finding out when what happened.
So basically you're saying that we can create a delta report in terms of what we said it should be and what it is on at present.
Exactly, and that has been used by developers all the time. That's why developers checking the code so that they can control the version. They should be able to see the differences over there, and they should be able to pick it up where the problem happened in their application code.
So basically infrastructure as a code and configuration as a code brings those good habit of developers into infrastructure world.
Exactly. There are tools we are not talking about much about tools like PowerShell DSC or Chef or Puppet, but in incoming sessions we are going to have separate session for that.
So the Chef, Puppet, and DSC, these are configuration management tool, whereas JSON is infrastructure as a code tool, am I right?
So infrastructure as code and configuration as code can be seen as a subset of infrastructure as code. So they are not separate. Configuration as code can exist separately, okay? But configuration as code is part of infrastructure as code. Infrastructure as code is someone who is the master. And
so basically, when you'll implement infrastructure as a code, you'll also take it to the next level where you're even making sure the configuration itself is also, is as a code.
Right, exactly.
Okay. All right, good.
Yeah.
So with that, let's move on to, so how does this, completely plays the role of, the entire picture of continuous integration release management? How do we relate these two in the bigger picture?
Okay, so configuration as code, as I said that from the infinity diagram, you can see that configure is part of operations. But when it comes to the, the CI, which is build. So build is something, CI is a pipeline, which what it does is, what exactly it does is it builds the code on the go. As soon as developer commits the code into the repository, the build will be triggered, and it will compile the code, it will run the test, and it will make sure the code checked into the repository is fine as far as build is concerned. I mean, there is no problem in build, and there is no test failure there. I mean, all the tests are running fine. The unit tests mostly we run in CI build. So CI build is something related to developers. When a developer checked in the code into the repository, earlier it used to happen that code either got compiled by the developer itself on the local machine, and then they give the artifacts. Artifacts is something which gets generated, the binary gets generated after the compiling the code, and that binary was provided to the infrastructure people. Okay, these are the binaries of my website, these are the binaries of our web application or something, and then that should be placed into the so and so folder of the server. So that's how it used to happen. That's how it happens when there is no CI pipeline or CD pipeline. So what CI ensures that as soon as you commit the code into the repository in the version control, CI pipeline will be triggered. It will build the code on the build server. There are multiple options you have. One of the options you have is VSTS build server. You can have your different build server as Jenkins as well, and there are different build server like AppWare as well. So I mean, those build server will make sure that your code compiles perfectly, apart from the local system of the developer. Sometimes it happens like on the local system it got compiled, but when you compile it on a server, it has configuration drift, as we talk about the the Snowflake servers. So the CI will make sure that Snowflake is not actually creating problems.
So just to help me understand, so continuous integration will make sure that we have consistent configuration across the environment. Am I right?
Exactly. Not exactly. CI will not ensure that. Configuration management will ensure that, but CI will make sure that if there is any configuration drift into the local developer machine and the servers we are deploying to, then the build server will detect that, and it will not compile the code, even though it was compiled on the local user's computer, and the compilation will fail. So and it will help you to move forward into the production server where you're deploying it. So CI will make sure that compilation isolation is
so I mean, if CI role is, it'll check at the configuration management, it'll look at the Snowflake servers. If it finds Snowflake servers, it'll stop the build. It will not compile the code.
Right. It will not compile the code, and compilation will fail because you have a standard build server over there, and the standard build server will make sure that the build process you have standard is compiling the code committed by the developer. Yeah. Okay. So once you have the compiled code, then it comes into the release management. So release management is about, once you have the compiled code, it is a binary. So either you are coming from a developer background, either you are coming out from operations background, that on the servers you deploy the end result of the binary, not the code itself. So the binary you get from CI, and then you have a next pipeline which you call release management, where will you deploy it. And for the deployment, we have two terms like continuous delivery and continuous deployment. And Deepak can explain more about it, continuous delivery and continuous deployment, what exactly it means.
Okay. Yeah. So basically, what we are doing at the moment is we are looking at the entire tool chain, right? We are looking at the holistic picture here. So whatever developers are doing and how they are like handing off stuff to ops, and then ops takes care of the deployment, the configuration, the monitoring phases. So the terms like continuous integration, I'd like to just again visit it, says that you always have working code living inside in your like master branch. So continuous integration makes sure that you always have working piece of code living in your branch. Okay, so what it does is it's sort of like whenever a developer, like you could think of a scenario where you have like 100 developers working on a product, and suppose I'm a developer, I am working on a feature, I checked in something, but it sort of broke the build. So what should eventually happen is this broken build should stop the entire pipeline, right? So that's where continuous integration comes into picture. What it does is like whatever I am developing shouldn't be in a silo. Whatever other people are developing, that it should always integrate with that work. So suppose I could be working on a feature which eventually breaks somebody else's features. So continuous integration is the gatekeeper which makes sure that whatever I am developing is in sync with, is also integrating with other people's work. Okay, so once you have a build, successful build, which basically means that you have artifacts. Artifacts could be something like exe files which are being generated from the C# code, or they could be PowerShell module files, right? They are just basically the end results, as Ashish explained. So once you have those things, you want them to be always deliverable. What I mean by deliverable is they shouldn't be lying somewhere on a system where they can't be reached. Like you should have a repository which everybody can reach to and grab those artifacts at any point in time. So continuous delivery just makes sure that okay, whatever wherever your build ran, whatever artifact is created, this should be deliverable at any point in time to any system.
So basically, that's artifact repository. So continuous delivery is, if I can say, it's artifacts repository. And how do we distribute that, basically, these artifacts, right? Okay.
Yeah. So you make sure that your artifacts are always deliverable in a continuous fashion. Like as soon as a build finished, that artifact should be deliverable. So you are making sure that the entire continuum which is being followed is in place. Like all the artifacts which were developed, which were built successfully, are available for someone to go ahead and take a look at it. So why do we do this is like as soon as my build finishes, you might have your QA team which want to take a look at the builds or the artifacts, and probably your security team which want to take a look at the artifacts or something like that. So you want it to be continuously deliverable at any point in time. And continuous delivery, like continuous integration, is sort of like the base on which continuous delivery builds on. So if you don't have continuous integration, you cannot reach continuous delivery, obviously, because you don't have a process in place which makes sure that the builds are consistent. So once you have continuous integration, then you sort of rack continuous delivery on top of it. And once you have continuous delivery, then you have continuous deployment. So
which is the actual deployment of the artifacts, which goes in production.
Yeah. So many organizations only do continuous integration and continuous delivery. They sort of have a manual process where somebody goes and reviews the artifacts and then they deploy it to the production systems. But companies like Facebook, Netflix, what they do is they practice continuous deployment. And in continuous deployment, what happens is as soon as the continuous integration build, CI build succeeds, it's the continuous delivery kicks in, which makes the artifacts available, and you have something called continuous deployment workflow, which sort of takes the artifacts and deploys it to the production dev staging environments. Now the key piece here is because you have sort of automated process where there's no human, then what makes sure that whatever your artifacts are or whatever features you are being developed are to the highest quality. So that's where testing comes into the picture. So testing is of paramount importance when you are trying to sort of practice all these things which we are talking about, right? Continuous integration, continuous delivery, continuous deployment, right? So testing, you would have seen that like there are different kinds of testing. There is unit testing, which basically says the developers will be writing tests for their logic, the code logic. And then we have integration testing, which makes sure that, okay, two developers or multiple developers working together, when they merge the code into a single branch, then everything also works. So integration testing takes care of that. That's another gatekeeper. Then you have something called functional testing. Functional testing or system testing, which says that when your entire application deployed to a particular, as a like when your entire application code deployed to a system, because application code cannot or your artifacts are not the actual deliverable, right? You deploy it on a system, and that the whole thing becomes your entire system. Then you test that, okay, that thing is working as well. So functional testing is in a very layman example, what you could do, what I could say is, you could have a functional test which makes sure that, okay, if you have a IS server rule enabled and you are deploying HTML artifacts to it, or web-based app to it, then you could simply do a curl request or invoke web request and make sure that the website is up and running, right? So functional testing would be those, and then there are a lot of testing which comes into picture, like acceptance testing, which would be from the developer side, and then we have infrastructure testing also, which is getting a lot of attention at the moment in the industry, at least on the operations people side. So like testing is of paramount importance, and because you're running these tests at different stages, you always want it to be automated. You don't want someone to be manually running these tests. Someone could do that, but ideally in your release pipeline, all the tests would be automated, and they'll make sure that these tests will make sure that these are the gatekeepers which sort of move change inside your organization or your environment.
All right, good, thank you.
Now, yep. And after your test, like Ashish kept on mentioning OODA cycle. So because you are testing it, your testing might not be always perfect. You might be writing tests, but you might not have always the entire coverage. So what will happen is, there's where performance monitoring comes into the picture. Suppose all the tests passed, the application got deployed, but we are seeing spikes in the performance requests. The server
So
is
this is where, like, different tools comes into the picture, right? Like, yep. Microsoft has App Insight, and then you have App Dynamics, which monitors the performance of the application.
Yep. Yeah, and no one thing works entirely for everyone. Like, I might be using different sets of tools. Somebody else might be using different set of tools. So ideally, like we say, right, the lean methodology says, like, whatever is not bringing value into your product is a waste. So actually developing a CI/CD pipeline would be waste. So you just want to do a minimal viable product. You just want to have minimal viable release pipeline ready for your environment. You don't want to, like, whatever works for you. If it works, then you don't want to invest much more into it.
Okay, all right, good. So let's with that move on to the next slide. And we do have questions, so we'll take those questions. We're running a bit late, so let's finish this and then we'll take the questions afterwards. And in the meanwhile, our team members is trying to answer those questions in the chat. All right, Lashish. Ashish, you there?
Sorry, I was on mute. Sorry, I was on mute.
No problem.
So let's talk about DevOps habits. So what are the habits you should have in your organization across the team, so that they all, embrace the culture of DevOps? And as we have talked about across the slides, it's all about culture. It's all about change agent and the mindset. So those are the these habits will ensure that all people are in line with that particular mindset. They are keeping up with the culture. So the first thing is team autonomy and enterprise alignment. So as Ruxar has also asked question about it, what is self-sufficient team structure in the DevOps culture, and how team work actually. So team autonomy should be there. As we talked about, and as we have seen the infinity diagram of DevOps pipeline, that there are few responsibility of operations team, like configuration management or maybe monitoring, and there are separate responsibilities of development team, like creating the code and verifying the build cycle or testing. Those things are there, but at the same time there are some responsibilities which are kept into the shared criteria, so that they should be aligned with the enterprise alignment. They should be keep up with the enterprise alignment. So team autonomy and the enterprise alignment should be mutually inclusive, so that whenever the team is acting, they should keep in mind that the end goal of delivering value to the end user is kept in mind. So that's what team autonomy and enterprise alignment is. If a developer is making some changes which he thinks that can be architectural change as far as application is concerned, so the operations team should be kept into the loop. It involves another question from Ruksar as well. As Ruksar asked one of the question where he said that how should we decide what are the application, what are the environment variables we are going to have in our application configuration, and in the environment variable, or maybe in the variable of configuration integration and release pipeline. So these things will be defined in the planning phase, and as you can see, the plan thing is shared between the dev and ops team. So that's how enterprise alignment habit should be there, while giving autonomy to each team, giving autonomy to each role. Then we have rigorous management of technical debt. Okay, so you have to keep in mind that you are managing your technical debt. Technical debt is a very common term used by developers, so they are very used to it, that if they have a code and the testing is not properly done, then the technical debt is very high, because the code is working, but the maintainability of code is not convinced enough to give the future support. So technical debt in terms of infrastructure, again, it comes on the same line, that when you follow the DevOps habits or DevOps practices, you follow the configuration management and infrastructure as code. And when the code is coming, then you will be dealing with the same practices what development team is dealing. So technical debt for your configuration as code and infrastructure as code should be maintained as equally, should be kept in mind as equally done by the developers. So, that's what technical debt means. You have, your code is not maintainable. It might have some tests which are failing. Maybe the application is working, but the tests are failing. So you should keep in mind, because those things will haunt you down in the future when you are scaling it up. Then we come to the focus on flow of customer value. So now the end result of any team or any organization is adding the customer value. So whenever you are working with any sprint, if you talk about the agile from the developer's perspective, or whenever you are talking about any infrastructure change, you should always keep in mind that you are adding a value to the customer. So the customer, like suppose you have a website, so website should be accessible while making changes to the configuration, or maybe the infrastructural changes from the operations team. They should keep in mind that this application or this feature should be available, should be online, because this is our customer value. This is the thing which is actually aligned with the enterprise, vision. So that's how, whenever you make changes, whenever you make plans, you have to keep in mind the customer values of the, or of the organization. How you, what are the things you are going to deliver. Then evidence gathered in production. This is something related to monitoring, and this is something will always help you in achieving or giving you continuous improvement over your application. So evidence gathered in production means that once you have the live application, then you should have a proper optimized monitoring system, which should get the correct telemetry data from the system, so that you can apply your OODA loop over there, observe, orient, decide and act, so that you will be able to observe the application behavior, and you should be able to decide, see whether it is, giving the customer value as expected or not. And then, you have to orient and then further, so that you can keep on continuous improvement. You can keep on adding the values to the, end user. Then DevOps habits embraces hypothesis-driven development. So what it means by hypothesis development? Hypothesis-driven development means that once you, I will take the example from the previous point, evidence gathered in production. Once you have the evidence gathered, once you observe the evidence, once you have observed the logs you got from the monitoring side, then you have to, you have to apply some hypothesis, like these are the things might be not working for the user, because that's where someone is failing. Like suppose you have an e-commerce website, and your monitoring application is reporting that 30% of the user, or maybe 40% of the user, a significant number of users are actually leaving your cart after going to the payment page. So that means that they are trying to pay, go there to pay, to buy things from your website, but then there might be some issue they are facing, and then they are failing, and that's why they are leaving your website and they are not buying things in their cart. So that telemetry data, you will have to get that data, observe it, and then you will have to apply some hypothesis. What are the things you might encounter that, okay, you are in India and you have not given a payment option supported by Indian RBI. Maybe you are the PayPal option is not there, or maybe MasterCard option is not there. So that kind of hypothesis will help you to give a feedback system to the developer. Okay, these are the things I think we should be including in our system so that it can add value to the user, and it might succeed or it might not succeed, because it's a hypothesis, it's an assumption. And if it will succeed, then you will get the value faster. And if it does not succeed, then again you will apply some hypothesis. So that's how the hypothesis driven development happens in a DevOps culture. You should always think like that. And as Deepak has also explained in the very first slide, that the change agent. So the change agent and hypothesis driven development gives you a very strong hand to embrace DevOps culture into your organization. Then we have life site culture. So life site culture is something related to focus on flow of customer value, but life site is something different. Like whenever you are making changes to a website, or if it's a website, or might be a server hosting some other enterprise application, maybe SharePoint or something. Whenever you are making changes and those systems supposed to be live, supposed to be online, then you have to follow practices and pattern which will embrace live, which will include the life site culture. What do we mean by life site culture? That there are different patterns we follow, like blue green deployment method. Like you will have two versions of website at a time. The blue is something new and the green is something which is already there, and then you will make sure that blue is having all the things by manual testing or maybe some load testing and things like that, and then you will change it to the green, and by using the slot options you have in your VSTS or any other option. So live site culture is something your website should be always available. Your site, your endpoint should always be available, because that's the end. That's the customer value you have. So your changes should not impact the existing system. That's the brief about it. And then we have manage infrastructure as flexible resource. Now, it's something related to configuration management, where you will let's get the feedback from the let's get the idea from Deepak. What exactly we mean by flexible resource in the infrastructure?
Yep. Okay. So the key point here is, like, I would take you a little back on how things used to work. For deploying a simple VM, a developer would first create a request, then that request would go to his manager, then his manager would approve it, then it would go to the infrastructure team would spin up the server, patch it, give the server back, and then the developer starts working on it, right? So what's happening here is, like, those things are basically things which get repeated on and on. Like in the earlier stages, might be we would have required some sort of approval for those things. But these things, at the moment, with the invent of cloud computing, are very regular. Like instances come and go like anything. What I mean to say by that is it should be very flexible. It should be very easy for someone. If somebody wants to quickly deploy a VM on Azure or any cloud vendor for that to suppose, they should be able to do that. There should be flexibility involved with it. And that basically comes from the notion or the idea that you should treat your infrastructure as a very flexible resource. It shouldn't be very hard for someone to just get up to speed, start working on something. So that's the key takeaway. That's why if you would have heard of something like self-service come into picture at very beginning, where private cloud products came into the picture, where there would be a self-service portal, you could just go ahead and like kick off things. Azure has something called Dev Test Labs, which lets developers request VMs from a pool and start working on it. So that's a key point when like your company or your team is starting to embrace DevOps. Do not have unnecessary processes and approvals in place, which might hinder the productivity.
Yep. That's a good point. So, like, it's not only about the culture, it's also about the culture, and it's also about the technology that we use. Make sure that, you have totally automated resource request process, and you have to break that. If it is a manual, if team is working in silos, you have to break that.
Yeah.
All right. So let's move on to the next slide. Sustainable DevOps.
Right. So as we have already discussed what DevOps is and what are the practices you should have, configuration management, infrastructure as code, CI pipeline, release management, testing, monitoring. Now, sustainable DevOps, I have put in this particular thing over here to give a brief slide or a brief area where you can see what are the things you should just have in your mind when you are starting with DevOps. So the first thing you should have in your mind, that is version control. If you are, if you want to include DevOps wherever you are, whatever the thing you are doing, maybe small thing, maybe a script or something. Whatever you are, doing, and you can see that, okay, this is a script I'm writing, or maybe a JSON ARM template, or maybe anything. You have to keep it in a version control so that you can maintain a version, so that you will be able to, at least manage flexible resource, what we discussed in the previous slide. Infrastructure as flexible resource. That means the version control will be there so that your infrastructure will be controlled by the version, so that the changes are, documented. You should be able to track it down, what are the changes you have made to a script or to a ARM template or to a DSC resource or whatever you're writing. And the version control is something which is very common among developers. So developers know that. They have been using it for quite a while. Because that's the feature you have to bring it in your infrastructure as well. Because if you are about to get into the DevOps practices, get into the dev version control. There are multiple tool sets. Just go through, the one which works perfectly for your team, for your organization. GitHub, Git, SVN, Visual Studio Team Foundation version control, or Bitbucket. There are lots of tools. Any one of them, pick it and just get started. Then we have build and release. Again, if you have an application, if you are deploying something, and then if you have a manual process over there to build, suppose developer supposed to build it locally, or maybe you supposed to build it on a central server or something, then that should be automated. Just go ahead. There are lots of tools available there. VSTS is one of them from the Microsoft, and as we are someone who, most of us are coming from Microsoft stack, because we are talking about Azure, then VSTS is something I would recommend. But then with having VSTS in mind, you have AppWare for CI, which Deepak can share his thoughts about it, because he is using it. You have different tools as well. Deepak, can you share how you are using AppWare?
Deepak? I think he's on mute. Let me unmute him. Okay, we lost him. That's fine. So let's proceed.
Okay. So I think he's okay. Yeah, I think he's offline. So yeah, I mean, AppWare is one of them. VSTS has build servers, hosted build server. You can host your own build server. So I mean, recently Microsoft has released Mac hosted server build server as well. So you can build your application artifacts, supported by Mac, supported by Linux, and obviously Windows is already there. So those things are there. Build should be automated as well as the release. So if you have a release cycle where you are doing manual copy paste thing, maybe a manual intervention is required to have a binary, keep it from somewhere, someplace, and then paste it over somewhere on the server. Then try to see what are the options you have to automate it. You might not be able to automate it completely, but that's fine. As long as you are improving on, it doesn't matter how much you are improving. It might be 2% in the beginning, then over a period of time it might be 20%, and who knows, it might be 100%. So that's how you should start working on it. It's not like you will implement the complete cycle. You will have to have a role of change agent. You should see things like a change agent. You should do a change, maybe a little bit. And then we have a backlog. So manage your technical debt. So as we talked about, and developers deal with it a lot. That's why the test-driven development came into the picture.
So can you define what is technical debt? What do you really mean by technical debt? I keep hearing.
So technical debt means that suppose you are writing a code. Okay, I will talk about it from the infrastructure perspective because developers knows it very well. I will give an example of developers as well. So let's first discuss it from the infrastructure perspective. Suppose you are writing a script. Okay, you are writing a script to do something with your server, maybe a DSP configuration, maybe a PowerShell script just to deploy on this Azure or maybe on-premises configuration thing. Once you have this script, it is working fine. Yeah, it is working fine. But then you have created the script, and over a period of time, it has been checked into the version control. But then there is a requirement came into the picture where you're supposed to do certain changes into the script so that it can support other things, like suppose you have created a script for a single server, but now we want that script to be working for a list of server as well. And now okay, so you created a script which is not a function. The first mistake you did, you created a script, you did not create a function. As far as PowerShell best practice is concerned, you should create a function. The second mistake you have already done, as you have not created a function, you have not created a parameter. So since you have not created a parameter, I cannot provide parameter into the script.
So basically, technical debt is something where you have got a workaround, but that's not the permanent solution. And with that workaround, you're able to deliver.
Right. But this is not as per the best practices.
Right. Okay,
I mean, this is not something.
I mean, still your delivery will continue. You will be able to deliver what you're expected, but you're not delivering in the best possible way.
Right. And in the future, what will happen? You have to pay for it. How will you have to pay for it? Because you have not incorporated those parameters, files, and function. What will happen? It will be difficult for you to update the server names on each and every place you have mentioned the server name or maybe the computer name, and it will take more time to update those changes, and that's how this becomes a debt for you, and that's how we call it technical debt. And more or less this is the same line from the developer's point of view as well. They create functions, classes on daily basis, and if they have not created classes as per the industry standard, I mean from their organization standard. Suppose they are creating an API and they have not created functions as per the documentation they have. Then in the future, if some junior developer will join in, he won't be able to relate it with the documentation provided by the organization, and then the technical debt they will have to pay for updating a code which could have been done in 15 minutes. They have to the junior developer will take 1 hour maybe, or maybe more than that. So that's how the technical debt technical debt means. Testing and monitoring. So as we said, version control is one thing, build and release the other thing, backlog is the other thing, and these all things are a part of journey. So don't take all of it in a single way. You don't relate them that even if you are missing one of them, then you might not be doing DevOps. It's not like that. It's a journey. You will first start with one thing, and then you will continuously improve on it, and then you will try to include as much as habits, as much as practices, as much as things available as per your organization, as per as your need. It's not like that you will have to have the backlog or technical debt, or you're not doing DevOps. It's not like that. If you're doing build and release, if you're doing version control, and as far as you are improving on things, earlier it used to happen like 2 hours of deployment time. Now if you have made it to even one hour and 20 minutes, that is also you have achieved your you have been able to reduce something the time. And then testing and monitoring. So testing monitoring again comes into the picture, that whatever you are dealing with, maybe infrastructure server, maybe applications, maybe platform as a service, maybe microservices, whatever the things you are dealing with, you should have a way of implementing testing and monitoring. So testing should be there, and as much as automated it can be done, that's a very good thing. There will always be a scope of few manual intervention in the testing, but that's fine. But see what are the options you have, how you can automate most of it, and then monitoring, so that you can give a continuous feedback to the development team, and they can improve on the application side, and so that you can have your DevOps cycle continues, goes on. It's not like you implemented DevOps once and it's all done. You will always have the improvement area.
So I think the next slide talks about the continuous, the complete life cycle, or all the components involved into.
Right. This picture I have included, just to give a picture of what are the things we have from Microsoft, since we are talking about Azure DevOps, and our primary focus is right now we are talking about philosophy, which is more of a generic topic right now, but with the time we have to focus on something, and that's our Azure stack, Azure or Microsoft's infrastructure stack. And from the Microsoft end, they give two tools which comprises most of the tools you will need for DevOps practices. Team Foundation Server is on-premises solution, and Visual Studio Online is cloud solution for the same thing. More or less, they both give the same feature. There are few differences, but more or less they give almost same features. And Microsoft is improving Visual Studio Online to give exactly the same feeling of having a Team Foundation server. And as you can see over this stack, that you have source control, you have agile planning, you have test case management, you have build automation. Whatever the things we have talked so far. Yeah. While thinking about DevOps philosophy, what are the things you should be thinking, and these tools, VSTS, these options will help you to achieve those things. So before coming into this picture, you have to think about the previous slides. Don't come into this picture directly. That's our recommendation. Go ahead, find the people and process, find the culture, be the change agent. Once you are the change agent, you know what you need to do. Then only you will be able to pick this feature from the Visual Studio Online, maybe Team Foundation Server, or maybe something from open source, or maybe, who knows, you can develop it yourself if it's not available in the marketplace. You develop it to automate in your organization, and a script, maybe a PowerShell module, maybe a DSC resource, maybe, I mean, there are different options you have. Can we have next slide?
Yeah.
Okay, so now we have infrastructure as code and DevOps. So as we discussed, what is infrastructure as code, and since we have completed the brief discussion of what DevOps means, what are the things you can, you have to relate with, how you can start with, what are the things you should be keep in mind when you are starting with. We thought of having a perspective from the infrastructure point of view. So infrastructure as code and DevOps in Azure is something will give you the starting point in the Azure from the infrastructure point of view. Apart from CI/CD pipeline, these are the things you can start with. To start the DevOps culture as an infrastructure.
Yeah, so this really excites me, right? I'm an IT pro guy. I'm not really into development. I'm not a developer. So this really excites me as how I can bring DevOps into Azure. So Microsoft offers different tools in Azure which lets you use infrastructure as a code. So the first one is your Azure automation. That's the automation account that you can create in Azure to run your scripts in automated fashion without any intervention, right? So that I certainly enjoy, and the lot of automation that we do using Azure Automation, and Azure Automation is based on Microsoft Orchestrator. So if you have worked with Microsoft private cloud environment in past, so System Center Orchestrator is what is the engine, is the brain behind the Azure Automation. And then I think you did talk about DSC, desired state configuration, which is a PowerShell DSC which enforces the configuration, as in IIS. I have installed IIS, certain configuration has to be done in IIS, like website, the SSL, and all those things which we can enforce using PowerShell. So PowerShell DSC is what helps you to enforce those configurations and make sure that it applies all the time, and even if it is out of sync, it will make it get back to sync. And then finally, you have ARM template, Azure Resource Manager template, right? So this ARM template is JSON format, Java Service Object Notation format. It's a declarative template of what kind of infrastructure you're building in Azure. That's where you define your basically you declare your templates, declare infrastructure as a template, and you use that to deploy in automated fashion the infrastructure in Azure. So anything you want to add, Ashish, or?
Right. Quite briefly, you have mentioned all the points. And Deepak, do we have Deepak now, or
yes?
Okay, Deepak, do you want to add something? Because I know that you have been using infrastructure as code quite extensively, so you might be giving some perspective from your.
So yeah, right on, you won't be able to practice infra as code to a very high level. It'll take time and practice. Certain infra as code principles say that you shouldn't ideally, if you're deploying a VM on cloud, you shouldn't be remoting into it. It should be a the concept of immutable infrastructure comes into place. Once you have your pipeline kicking off VMs on the cloud, your configuration management coming up and configuring those. If there's a change required on those boxes, you shouldn't ideally be connecting over RDP or PowerShell or SSH and making those changes. But that would be the end state which you want to reach at some point in time. So basically, by following infra as code, it'll make your life very, very easy. If you are following infra as code to the highest level of discipline, then you don't have to worry about at the end stage if you want to fix something, because you already have the understanding of your infrastructure. If you want to revert back some changes in your infrastructure, you could do that ideally, because your version control is the source of truth for your infrastructure. It has the ARM templates, which basically define how your infrastructure is modeled, is designed, and Then you have your workbooks which do some sort of repetitive tasks based on a schedule or something, and you have your configuration management in place, which is making sure that the VMs which have come up are always in a desired state. So that would be the highest degree, but I would suggest you to go ahead and take a look at the ARM templates, because ARM templates lets you do repeatable deployments. So if you're just starting with Azure, try to do a deployment of a storage account using ARM. Try to do it using PowerShell, and then start making it a little bit complex. Then start adding virtual machines, then start adding next, assigning public IPs, throw a load balancer into the mix. Then you will come to a point where you realize, okay, why ARM templates came into the picture, because writing imperative code where you have code which will basically deploy infrastructure does not make sense in a cloud design pattern. You should have something like a template format which makes sure that whenever you deploy your infrastructure, it is guaranteed that it follows that particular schema, like infrastructure schema, you could say. So ARM templates basically are standardizing your infrastructure which you are deploying on Azure.
All right.
Right. So as Deepak has emphasized that that having end-to-end infrastructure as a code is something you should always think about, but do not start with that particular objective. Objective in your mind on the first place itself. It's a journey. Infrastructure as code, as DevOps, is a journey. So infrastructure as code is also a journey. You will start having that particular mindset that whatever you are deploying, if you talk about on-premises, so whatever the configuration changes you are doing manually, start thinking on the PowerShell line. You do the scripting work. If you talk about Azure, if you are doing it either using portal or some other way, PowerShell, inline PowerShell script, then start coming into the ARM template. Once you have the ARM template, you start adding resources over there. First you will create VM, then maybe you will add other resources like public IP. Yeah. So on the same point, you will start having PowerShell DSC in some point of time, adding to your infrastructure as code, and then you will start having other tool sets like Chef, Puppet, and all those things. So it's a journey. So that's why I have said the starting point. So Azure automation, if you talk about Azure automation, the first thing you should know about, if you are an infrastructure person, desired state configuration, start exploring it, and ARM template.
All right, good.
Just
Thank you.
go.
Thank you, Ashish, and Deepak. I think this is the last slide. So, what we'll do is you can always join our the Telegram group. So Azure DevOps Telegram group. You can go to http azuredevops.cloudeasy.com. That will redirect you to our DevOps Telegram, and then AzureTalk Telegram, which has more than 2,000 members. So you can go to http azuretalk.cloud with k cloudeasy.com. That will redirect you to our group. And if you want to refer all our Azure past talks, so you can go to our website www.cloudeasy.com, and from there you can refer it. With that, I have unmuted all the participants. So if you have any questions, please feel free to unmute yourself and ask those questions if we have not already answered in the chat. Any questions from participants? And you can unmute yourself.
Niraj, this is Mahapati. So I have a question. Is it Niraj, are you able to hear me?
Yeah, I can hear you. Go ahead. Go ahead with your question, sir.
Yeah, my question is can anyone can help me for how can I create a service fabric cluster in stateless mode? I chatted the question, but I didn't get any response. Is it DevOps team can help me to create a service fabric cluster with a stateless mode?
So, well, for that, probably we in the past we have taken a session on Azure Service Fabric, and you can refer those sessions. But we'll at this point of time, I think it will be a little bit out of context, but we can certainly help you if you can post those questions in our Azure Talk Telegram forum, and we will be able to help you there for sure.
Okay, thank you.
Any other questions? All right. So if you don't, go ahead.
And Niraj, yeah, please go ahead.
No, I'm okay. I'll stay on. You can go ahead. You start off first.
No issues. So this is Lalit. I just wanted to appreciate Ashish and Deepak and Niraj for DevOps. It's really, I even doesn't know about the DevOps, but when I just gone through this session, I am able to understand that how the infra as a code and what other DevOps would be, integrate with the infrastructure and make the life easy. So thank you so much, Niraj, Deepak, and Ashish for having this session.
Thank you. You're welcome, Lal. All right. Cycle. So you had a question?
Yes, sir. My name is Arun. Can I ask you a question?
Yeah, please go ahead.
Thank you. Firstly, Guruji, thank you very much. And Ashish and Deepak, it is really great that you guys are helping us out with the DevOps. And I had a false impression that this is going to take me a long time to understand and correlate to what work I'm doing right now. So after this session, I'm really enlightened, and I feel yes, this is the right approach that can be included in the organization. Thank you very much, all three of you, and the other participants as well, who are part of the meeting. Thank you, everyone.
All right, thank you, Arun. Thanks for taking your time and sharing your feedback. It really helps us, and it also helps us deciding on our future, topics, and also how to deliver it in a better and easy way. So I really thank you for your feedback.
Thank you, Guruji. And my question goes this way. I had a feeling that we can include the test cases along with the test builds as well. Validating the build and release time. So can we include the test cases along with that, where we could validate our build before deploying the developer code? Was my question.
Okay, so are you talking about the unit test?
Yes.
Okay, yeah. I mean, you can definitely include your unit test, and there is, I mean, in VSTS, because I work on VSTS a lot, so I know in VSTS CI pipeline, you have tasked to include a test, having include the test in the build itself, and if test fails, you can decide upon like build will fail, and then it will not go forward.
Right. So okay, let me rephrase this question again. I'm sorry to ask it this way. Okay, let's say when we are speaking about continuous integration, we have unit test cases that can be performed, right? Whatever you just explained, if I'm correct.
Right.
Right. So when we speak about continuous deployment, is there a way that we can integrate, the test cases there as well, to automate the process as well?
Okay, so as far as VSTS is concerned, VSTS tasks are very much flexible. Okay, so because in release you won't have solution files. So as far as .NET application is concerned, so if you do not have solution file, then definitely you won't be able to reference the solution file in the test test task in the VSTS at least. But if you remove the unit test, you can have load test. It is like relevant test in the relevant pipeline. So unit test is more about testing the source code, so it should be there in the book itself. And the load testing or other, yeah.
I would like to add to him. So he's saying that after the deployment, like you have continuous deployment in place, the artifacts are deployed, then you want to test, you want to validate that everything is in place, right? Your infrastructure, right? So we do that sort of testing. We call it infrastructure testing or the systems testing. So ideally what you could have is make sure once the artifacts are deployed on your production server, have those functional tests or functional tests or your systems tests into the place. We use PowerShell and Pester a lot. So what we do is we make sure that everything is working properly, and if it is not, then what we go ahead and do is we probably destroy the whole environment which has come up on Azure. So we do that, like it's extensible. You can do that.
Right. Validation test he's talking about, right?
Yep.
Oh,
All right.
okay. Thanks, Deepak.
All right, good. So, any other closing questions before we wrap it up?
I'm good, Guruji. Thank you. Thank you, everyone.
All right, thank you. All right, so with that, we'll call it a wrap, and then I thank you very much for everybody for joining our call today. And as usual, we'll publish the recording of this session onto our website, and you can always bookmark the website cloudeasy.com/azuretalk.html. That's where we publish all our. In fact, there are all more than 26 sessions which are already out there. So if you missed any session in past, you can browse through that, and I've also posted the link in the chat, and you can just go through those previous sessions. So once again, thank you very much, everybody, for joining our call, and keep tuned yourself. We'll have more sessions on DevOps and other Azure topics. And if you want to be keep abreast of the new the sessions, please do register yourself by going to our website www.cloudeasy.com, and you will once you register, you will be in our distribution list, and you will keep receiving regular updates from us on next new sessions. So thank you very much, and we'll talk again next week or so.
Thanks,
Thank you.
Niraj. Thanks a lot.
Yep. Thanks, everyone.